So this is part 284C3M1b7C8E13C9C6D3P38D19b. It's line 22f1fa19C3M1b7C8E13C9C6D3P38D19b. Dipole antenna, doublet, UFO 5G Wow Seti. And there's the alien radio signal. And here's our data here. Okay. So, this is about a dipole antenna for a long-distance communication deep space device for a UFO spaceship found in the WOW data. So, February 24th, 2013, today's March the 11th. This is the keyword martensite-austenite crystals, we're still talking about that. From line 22f1fa19C3M1b7C8E13C9C6D3P38D13, and that one was called Nano Carbon Steels Metals UFO 5G Wow Seti. And there was a formula with it. It was I don't know from the data. It's martensite plus steel crystalline structure formed displacive transformation and hard minerals lath plate shaped crystal grains viewed cross section lenticular lens shaped crystal grains. So I'm going to mix the crystal grains in with obsidian glass and acicular needle-shaped crystals. Okay, so I'm going to Google the keywords together to see what comes up with acicular and crystal grains from a previous video, which we did already. That was in line 22f1fa19C3M1b7, C8E13C9C6D3P38D15, Diffusionless Transformation Metals 5G Wow Seti. Then I took the keyword acicular, crystal grains, and natural light, adding it to a bendable metals formula that was found in the WOW data. And that's in the previous video of line 22f1fa19C3M1b7C8E13C9C6D3P38D18. Zinc blend cubic crystal formula 5G Wow Seti. So the keywords from the data were natural light to zinc blend structure. Okay, so zinc blend structure and cubic crystal system plus a tetrahedral coordination create a dipole and dipole antenna will all be in the next videos. So that's from our previous video, line 22f1fa19C3M1b7C8E13C9C6D3P38D19 tetrahedral coordination magnets UFO 5G Wow Seti. So it all started in that section and just broke it down from several different videos. The reason I'm keeping them together is because it's all different formulas for this bendable metal, and there's been lots of stuff mentioned about it, but this is actual where the it actually starts showing us how to put it together. So this is a keyword for dipole antenna. Quotes in the diagrams are from Wiki. A dipole antenna is a very basic type of radio antenna. It comes in various geometries. Example, rabbit ears for television antenna with different reading mechanisms and radiant elements as a driven element in more complex antennas such as the Aggie. This antenna is the simplest practical antenna from a theoretical point of view. Dipole antennas were invented by German physicist Heinrich Hertz around 1886 in his pioneering experiments with radio waves. As of today, the dipole antenna is probably the most common antenna type. So it shows the length of meters in the ohm feed line. So, and then there's an elementary doublet that came up showing how, I guess, how the signal bounces or something. I don't know what that is. Theoretical. So they're talking about this being a theory. So from a theoretical point of view, the dipole antenna is the simplest antenna type. An elementary doublet or Hertzian dipole is a small length of conductor, small compared to the wavelength, carrying an alternating current. So there's the formula for that. And here W equals 2 pi f is the angular frequency and f the frequency, and I equals V to 1 or minus 1 or something like that is the imaginary unit, so that I is a phasor. I or L? I? Oh, great. They don't really, oh, it could be L as a phasor, I don't know. It is used in, for example, analytical calculation. I'm half asleep, sorry. I was up all night working on something. It is used in, for example, analytical calculations on more complex antenna geometries. Note that this dipole cannot be physically constructed because the current needs somewhere to go, or somewhere to come from and somewhere to go to. In reality, sorry, this small length of conductor will be just one of the multiple segments into which we must divide a real antenna in order to calculate its properties. In the case of the elementary doublet, it is possible to find exact closed-form expressions for its electric field E and its magnetic field H. In spherical coordinates they are, and there's all the coordinates. Actually, I'm making just a wee bit bigger so you can see what they are. Kind of hard to see that little dinky print there. There. Try this one here. I don't know why they always put these math equations in these little boxes. Easier to like make the print bigger. Okay, where R is the distance from the doublet to the point where the fields are evaluated. K equals 2 pi divided by, I think that's wave, is the wave number, and Z equals whatever that is the wave impedance of the surrounding medium, usually air or vacuum. So you can read those little math equations there, right? So March 9th, okay, my thoughts. R equals the distance from doublet to point where fields are evaluated. Another idea for R in the algorithms math equations from the alien astronaut video in line 17 T2b. Quote, math equations from Wikidata, formula R data is K equals 2 pi wave number, Z equals that algorithm with the wave impedance and surrounding air or vacuum. So quote from Wiki, the energy associated with the term of the near field flows alternately out and back into the antenna. The exponent of E accounts for the phase dependence of the electric field on time and distance from the dipole. Often one is interested in the antenna's radiation pattern only in the far field, where R is something to a waveform divided by 2 pi. In this regime, only the 1 divided by R term contributes, and hence, oh, we got some more math equations for you to look at. And we'll make them a little bit bigger for you. There you go. Just go this way. That works. This is fun doing when you're half asleep. There you go. Okay, so the far field electric EV, or a little V, that's a little V, I can't tell. Need a magnifying glass to see it. Of the electromagnetic wave is coplanar with the conductor and perpendicular with the line joining the dipole to the point where the field is evaluated. If the dipole were placed in the center of a sphere with the axis south-north, the electric field would be parallel to geographic meridians, and the magnetic field of the electromagnetic wave would be parallel to geographic parallels. So the keyword dipole antenna will be in the next video. It's probably going to be in the next 10 videos, just so you know. There's lots about it. Okay, thanks for watching.